Lesson 8.2 is the Pythagorean Theorem and its converse. The Pythagorean Theorem says the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. Most of us know this as a squared plus b squared equals c squared, but you need to know what each of those are. So given a right triangle where the right angle is c, the hypotenuse is always the side across from the right angle. And in this case, remember the vertex is a capital printed C. The length of the hypotenuse is a lowercase printed c. The lowercase a down at the bottom here represents the length of the side, the leg that is opposite angle A, and the lowercase b on the left here represents the length of the side opposite angle B. So the length of little a squared plus little b squared equals little c squared, recalling that the lowercase letters refer to the lengths of the sides. The converse of the Pythagorean theorem is also true. So if the sum of the squares of the lengths of the two shorter sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So in other words, if you take the two shorter sides and you square them and add them together, and that equals the length of the longest side squared, then the triangle is a right triangle. A Pythagorean triple is a set of three non-zero whole numbers that satisfy the equation a squared plus b squared equals c squared. In class, we've talked about 3, 4, 5 right triangles and how contractors use those to make sure that the corner of a building is square. Some other popular Pythagorean triples are 5, 12, 13, 8, 15, 17, 7, 24, and 25. And remember, the longest side is always the length of the hypotenuse. As well, you can multiply these by any number, a constant, and that also makes a Pythagorean triple, or will make a right triangle. So for example, 30, 40, and 50 is a right triangle, or 10, 24, and 26 is also a right triangle. It's helpful to know Pythagorean triples because you can actually save some time in doing problems if you recognize that one exists. And there are two Pythagorean inequality theorems. The first one says, if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. Or in other words, if c, the length of c squared, is less than a squared plus b squared, that means that c cannot be the hypotenuse of a right triangle. It's going to be shorter than the hypotenuse and will actually make angle C an acute angle. So if c squared is less than a squared plus b squared, then triangle ABC is an acute triangle. Also, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So in this case, if the longest side is squared, if that is actually longer than the other two squared and added together, then triangle ABC is obtuse. Let's try a couple examples. First of all, find x. Since this is a right triangle, we know the length of one leg, we know the length of the hypotenuse, but we need to find the length of the other leg. So I can say x squared plus 9 squared equals 15 squared, or x squared plus 81 equals 225, and subtracting 81 from both sides, x squared equals 144, and the square root of 144 is 12. Here's another example. Oops, I forgot to mark this as a right angle. Okay, so one leg is x, the other leg is 4/9, and the hypotenuse is 8/9. So x squared plus 4/9 squared equals 8/9. squared. Don't turn this into a decimal. Leave them as fractions. X squared plus 16 over 81, just square the 4, square the 9, equals 64 over 81. And subtracting 16 over 81 from both sides, x squared equals 48 over 81. And taking the square root of both sides, I had the square root of 48 over 9, which simplifies to 4 square root of 3 over 9. Here's another example. Determine whether the set of numbers can be the measures of the sides of a triangle. We did that, I believe, back in Chapter 5. If so, classify the triangle as acute, obtuse, or right. So the first thing we need to do is figure out, can these be the lengths of the sides of a triangle? So recall that the two shorter sides had to add up to a number greater than the longest side. So since 16 is greater than 14, yes, it can be a triangle. Now let's figure out what kind of triangle it is. Is it acute, obtuse, or right? Well, let's plug these numbers into the Pythagorean theorem and see what happens. So 4 squared plus 12 squared, is that equal to 14 squared? Is 16 plus 144 equal to 196? This adds up to 160, and 160 is actually less than 196. So since the longest side squared is greater than the sum of the other two sides squared, this is going to be an obtuse triangle. And our last example. Determine whether triangle XYZ is acute, obtuse, or right for the given vertices. So you don't need to graph this. Actually, I think we're going to use the distance formula. So we need to find the length of each side, XY, YZ, and XZ. And you can go ahead and use the distance formula in your calculator. XY comes out to be the square root of 8, which is approximately 2.8. Don't worry about simplifying it. YZ ends up being the square root of 2, which is approximately 1.4. And XZ ends up being the square root of 10, which is approximately 3.2. Now, the reason I gave decimal approximations for these is just in case I ended up with anything strange, I wanted to make sure I knew which was the longest side and which were the two shorter sides. So in this case, it's pretty clear. So we need to ask ourselves, is the square root of 8 squared plus the square root of 2 squared equal to the square root of 10 squared? Square root of 10 is the longest side, so that must be the hypotenuse, so that must be the C in our formula. Square root of 8 squared is 8. Square root of 2 squared is 2. Square root of 10 squared is 10. And yes, 10 equals 10. So this is a right triangle.